Villanova's Roboboat team is in a great position this year. Adapting designs from previous years, we're now implementing some innovative systems and techniques for more refined sensing and robust control. Some of our big changes from last year include incorporating a LiDAR into our vision system, upgrading our real-time target machine, incorporating a color sensor, and integrating some hydrophones. One of our big problems last year is that the code had to be built each time after a power cycle. This year, we can now build on an executable, save that on our target, and run on startup. This year, we won't be stuck in the dock.
The LiDAR is an optical range sensor that uses a laser to get distance readings on a horizontal plane. Using a gimbal that moves the LiDAR up and down, a full 3D scan is created for the boat to detect objects and obstacles. Raster scanning can be quite a slow process, so a new scanning method is being implemented which mimics laser view patterns. By moving the gimbal LiDAR system using the new scanning pattern, frame rate can be increased without dramatically decreasing resolution.
For this year's competition, a simultaneous localization and mapping, or SLAM, algorithm is being implemented on CCAT. This will build a map which will be used for path planning for the obstacle detection and avoidance task, as well as to track targets for other tasks. With the SLAM and the LiDAR, we can now shift to a posterior analysis of color. Targets can be detected in the LiDAR and tracked using the SLAM. These targets each have a finite number of possible colors, so a Bayes filter is being used for recursive state estimation of color in the hue, saturation, and value color space.
For the acoustics task, an omnidirectional hydrophone will be mounted on each of CCAT's two pontoons. An intensity-based analysis of the hydrophones will be done to orient the boat relative to the source. The buoy that the active pinger is attached to will be determined and the color identified by the boat's vision system. Both the color of the boat and its position will be reported back to the technical director for completion of this task.
Looking at the competition as a whole, in order to attempt tasks in a logical and strategic way, we use a structure called a finite state machine, which is programmed through Simulink. The FSM organizes each task of the competition into separate states which are enabled upon the completion of the previous state. For many of these tasks, we are taking a vision-based approach incorporating extensive filtering of characteristics like color space, blot extent, and frame location. One new algorithm that we are developing is a template-based filter, which compares the similarities of captured images with a pre-made template. This will be used to recognize symbols in this year's docking task.
We have SLAM. We also, for the first time, have a sensor fusion with LiDAR, and we're also looking at some kind of a Bayesian model to estimate buoy colors more accurately and to learn from step to step. So we are all pumped to go. The kids are enthusiastic, and we look forward to coming and putting up a good show.